Well, hello there. Welcome to lesson 8.8. This is on line symmetry, and I apologize for not getting the video up sooner, but I accidentally left my iPad at a friend's house. But the good news is, since this lesson is about line symmetry, he happens to be an artist. So I've got some of the various pieces from around his house, and we're going to use those to talk about what line symmetry looks like. So let's go ahead and start with the definition. Line symmetry basically means a figure has line symmetry if a line can be drawn through it so that each half, when you draw the line, each half of the line, each half of the figure on either side of the line will be a mirror image of the other. Okay, now the line that does this is called a line of symmetry. All right, let's take a quick example. All right, so take, for instance, this woven basket on the wall. Okay, if I take a line about like so, okay, and draw it down the middle, you can notice that the left half and the right half of this figure are basically mirror images of each other. Okay, so we would say that this basket, it's actually kind of like a paper plate holder, would have line symmetry. Okay, here's another example. This vase. Okay, if I draw a line right down the middle, you can see the left and the right half are mirror images of each other. It would also work on this raku vase over to the side. It's a little bit of a weird perspective, but if you actually looked at the actual vase, you can see that it is in fact symmetric. Okay, now here's an example of a pitcher. Okay, and this isn't actually one that he made, but if I try to do it here, okay, you can see because of the handle, the two sides are not the same. Now, if I turn the very same picture now, if I look directly at the handle and draw the line like this, with the exception of a little bit of the painting on the picture, the actual shape of the picture is in fact once again symmetric because again you have mirror images. Look at yourself, look at your face in a mirror and draw a line through it, and you know, unless you've had like some sort of really tragic accident, basically people, or at least their outsides, are generally symmetric. And a lot of the insides are symmetric too in terms of things like the skeleton. Now we know that the digestive system isn't perfectly symmetric. You've learned that, of course, in Miss Lounsbury's science class. But you get the basic idea. All right, so here's a figure. These are some wall plaques that he's made. And as you look at them really closely, there's no way that you can draw a line through one of these, okay, and get perfect symmetry. Okay, so this is an example. These figures right here are an example of something that does not have any line symmetry. Now you do need to be careful. This figure here is a really cool plaque that he's made, and you can see symmetry in it, but it's not line symmetry. And no matter where I draw a line, I won't get mirror images. Okay, so while it looks generally the same, if you look at the actual pattern, it's not really absolutely symmetric. However, most of the shapes, if you go around, this figure has rotational symmetry. Another example of something with rotational symmetry, let's skip ahead, would be yin-yang. Okay, the yin-yang symbol from the Far East. If you draw a line through the center of this, you can split it into two equal halves. Okay, and again, if you rotate the two halves around, granted we've changed the color from black to white and from white to black, so you do get two identical halves, but they're not mirror symmetric from each other. So that's an example. While there is symmetry here, again, it's rotational symmetry. So we need direct mirror reflections. Okay, let's back up for a second. Okay, this piece in the window is a good example. If you look at it carefully and you draw a line right down the center, it's a little bit off. Let me draw this line and move it over a little bit. Okay, right about there is a line of symmetry, so the left and the right are the same. Okay, just to the right of this piece is this tin piece, and again, it's got a lot of neat pictures, and the leaf itself almost looks symmetrical except for the curve, but if you put it all together, there's no place I can draw a line and get perfect mirror symmetry. So the big mistake people make with line symmetry is they get this notion that a line that splits things into two identical halves means you have line symmetry. It's more than that. You have to actually have mirror images. So the yin-yang is not. Another common example is a parallelogram. Okay, if I draw a line, there's a lot of different lines I can draw. I can draw a vertical line. That's a little bit off. Let's move it over a little bit. Okay, I can draw a vertical line. Okay. No, it's not going to work. Okay, so let me draw a little bit better. Okay, there's a vertical line. And it does split it into two. I can draw a horizontal line that splits into. I can even draw diagonals. And again, all of these will split it into two equal halves. but none of them are going to be mirror reflections of each other. Okay, so while it does split into two equal halves, we don't get mirror reflection, so there's no line symmetry here. Okay, so that's basically line symmetry. We're going to look at patterns both from geometry, just regular shapes, and also things in real life to determine whether or not they have line symmetry. Okay, so thanks for tuning in, and that concludes lesson 8.8 on line symmetry. Thanks for watching. See you in class on Monday.